Hello and welcome to pmclounge.com. In this video, we are covering some concepts of extreme programming that we have not covered so far. And the simple reason for that is the fact that these concepts apply specifically to software projects. Now, so far we have covered several topics, several concepts of XP, but they were broadly applicable to all kind of projects, all kind of industries, all kind of teams, right? But remember, the P in XP stands for programming. So there are certain concepts that are applicable only to software projects. And those are the concepts that we'll talk about in this video. By the way, if you're preparing for ACP exam, the PMI ACP, XP is something that you should be aware of. Even if you're preparing for your PMP certification, even if you're just a project manager managing projects, you should know about XP because this is one of the ways to deliver projects. So definitely check out the second link in the description below, which will contain all the videos that we have done so far covering XP concepts. Second link, because the first link is going to take you to an article over at our official website pmclounge.com, and that article is going to contain all the concepts that we are going to be talking about today. And these are the concepts that we will discuss today. We'll talk about embracing change. We'll talk about two values of XP, that is feedback and simplicity. By the way, there are three other values of XP that we have already discussed in the past in individual videos, like respect, then communication and courage, right? So these were the three values that we have talked about in the past itself. And those were individual videos. Like I said earlier, I'm combining all these concepts in one single video, and this is going to be a longer video for sure, because of the fact that these are concepts that pertain to code, that pertain to software project management, right? So on the agenda, you will also see version control. We will talk about peer programming, 10-minute build, continuous integration, TDD, refactoring, and tech debt. So these are the concepts that we will cover today. And as I said, so far we have explored XP concepts that aligned closely with Agile methodologies, and that allowed them to be applied broadly across various project types. But as I mentioned, the P in XP, it stands for programming, which means there are some concepts that are specific to programming projects. So if you work on software projects, if you work on projects that involve programming, then these are the concepts that you should be aware of. Now, let's talk about XP principles that are uniquely applicable to software development projects, starting things off with embracing change. Now, in the world of software development, change is definitely a constant. Projects evolve, requirements shift, and the code base must adapt accordingly. However, many teams, they are going to find themselves building code that's hard to modify, and that is the reason why many teams are going to struggle with modifying hard to read or complex code later on. The point is, if you consider a scenario where team members are asked to modify a piece of code that they did not write to begin with, right? Imagine how difficult it is going to be, and imagine the resistance that you are going to face, right? Somewhere, sometime back, 2 years, 3 years ago, a coder who was not that good wrote a piece of code, and now today you are a new joinee in this company and you are asked to fix a bug in that piece of code. This happens all the time, right? So first of all, you would need to understand the existing logic of the existing code, and then you need to figure out what needs to change. And finally, you will also have to implement that change and do all of this carefully, because it is risky, right? You might introduce new bugs in the system. You might not know what breaks where. So this is the reason why if you have easier to modify code, it is going to reduce the resistance that you are going to face from your coders, right? So if the code was designed to be easily modifiable from the start, you would have not faced this resistance. So XP focuses on practices that make code easier to modify. That's something that XP focuses on. So this is where XP excels, right? So There are programming practices that focus on simplicity, they focus on clarity, they focus on frequent refactoring. We will talk about what refactoring is later on in this video itself. And all of these practices, they make code easier to change as well as understand. So embracing change is key to success in software development for sure. That's why I wanted to talk about embracing change to begin with. Embracing change is one of the most important concepts in Agile itself, right? So this approach helps teams reach a point where they no longer resist change, but embrace it, seeing it as an opportunity for improvement rather than maybe some kind of disruption, right? So by adopting XP practices, teams can build a code base that's not only robust but also flexible enough to handle the inevitable changes that come with software development. When you are doing so, you are shifting from a mindset of resistance to a mindset of continuous improvement and continuous adaptation, which is what Agile is all about. So I hope you understood this first topic of why embracing change is so important. Now let's talk about one of the values of XP, that is feedback. Now look at these two scenarios. Scenario one, a programmer writes code which is based on the requirements that he or she got. Customer changes the requirements. Now this could be because of new market insights or new market demands and all that, right? Now when customer changes the requirements, your code needs to change. Now think about scenario 2. You write code based on the customer requirements, but the feature does not work, and this could be because there were some technical issues. Maybe the testing team found some performance issues or whatnot, right? So the feature did not work as expected, and that means you will have to change the code again. What this means is that it is pretty rare to get code that's 100% change proof on the first go itself. We just talked about these two scenarios and we realized how the code had to change. So the best strategy is to gather feedback early and regularly. Get feedback from the customers, get feedback from even your testing team. And that's why feedback is one of the most important values in XP. Now, feedback can come in several forms. There are 4 most important ones. We'll start off with peer reviews. That's the first form of feedback. Peer reviews are one of the most critical feedback mechanisms in XP actually. When teammates, they review each other's code, it's not just about finding bugs or mistakes. The review process also allows team members to exchange knowledge, learn from each other, and improve the overall quality of your code, the quality of your project, right? So all of this is being done as part of peer reviews itself. And this TOI, this transfer of information, is actually the key because it ensures that knowledge doesn't stay siloed with one person but spreads across the team, which is of incredible value for future work. And that is why peer reviews also build accountability and strengthen team collaboration as everyone gets involved in improving the code base. And let's go back to our initial example where we said that someone 3 years ago wrote a piece of code and they perhaps wrote it in a silo. Nobody else knew about that code. Now imagine if peer review was done. Imagine if one of the person who peer reviewed that code was still with the company. You would have not had to struggle with understanding the logic of that code, with making changes to that code, right? Now let's talk about the second form of feedback, which is code integration. Now, how can code integration lead to feedback, right? Now, if you do it frequently, frequent code integration is actually essential in XP because it helps catch issues early before they become major problems later on. The longer your code is going to stay on your own computer without being merged with the rest of the project, the more likely it is to become outdated or incompatible with others' work, right? Because there are other programmers also working on the same project, writing same piece of code, not necessarily same, but writing different modules of the code of the same project, right? Now, regular integration, what this means is you are constantly keeping your code in sync with the rest of the project. And if there are any conflicts or if there are any bugs, they can be detected sooner rather than later. And that is why frequent integration is the key, right? Frequent integration. Now, this practice also prevents massive integration headaches down the line where teams spend hours or even days trying to merge conflicting code bases. So, this is definitely all about catching potential problems early and catching them often as well. Next, let's talk about iteration. Now, we are talking about Agile. Obviously, we are talking about XP. Iteration is bound to come. Iteration is also a form of feedback. Iteration is actually a fundamental aspect of extreme programming. This breaks the traditional mold of software development. Instead of planning an entire project for, let's say, 6 months and showing the results at the end, what XP encourages you is to work in small, manageable chunks, right? We have done videos in the past talking about how you plan projects in XP, right? Do check that out. You will understand what weekly cycle is all about. So in XP, each iteration, which is 1 week long, also known as the weekly cycle, during this weekly cycle, the team is going to build a part of the project, they are going to present it, and they are going to gather feedback, right? And they are going to present it to the customer, of course, right? And they are going to gather feedback on it. This feedback, right? This is going to help them pivot, adjust, or even improve based on the real time needs of the customers, based on the real time needs of the stakeholders. This is also going to prevent surprises at the end of the project, and it ensure that what's being built is actually what the users want. And this constant refinement throughout iteration keeps the project aligned with the real world expectation that the customers, the stakeholders actually have. So that is why iteration is also a form of feedback. And finally, we have unit tests, right? So there are automated tests that actually catch breaking changes. And there's an entire concept about TDD, which we will talk about. But the point is, unit tests, they provide critical feedback on the functionality of the code itself. These are automated tests designed to ensure that individual parts of code, or let's say units of code, they work as intended. Now, what makes unit tests so valuable is that they remain part of the code base itself. And that means anytime a developer makes changes or, let's say, adds new features, these tests can run to verify that nothing is broken. Now, this is like having a safety net, right? That constantly checks the integrity of the project. And this feedback is also instant. So if something breaks, you know right away and can fix it before the issue grows into a larger problem. So unit tests basically give developers the confidence to make changes, knowing that even if something goes wrong, it will be immediately caught by the system and can then be fixed. All right, let's talk about our next concept, which is version control. Now, here's a scenario that you need to imagine. At 9 a.m., Shane copies the source code folder to his system to work on the code. So Shane came into the office. He's starting his work at 9 a.m. He did the copy of source code folder to his system and start the work. Now 10:30 a.m. Stacy shows up and she copies the source code folder to work too, and she has also copied it to her own system. At 2:30 p.m. Shane copies the updated vendor module.java. This is a module that Shane was working on, and he copies this updated one back to the shared folder. At 4 p.m., Stacy also copies the updated module. It's the same module, right? So Shane has already updated it in the shared folder at 2:30 p.m. But at 4 p.m., Stacy also copied over the same module back to the shared folder. Now, obviously, at 5 p.m., when Victoria comes in, she's going to realize that Shane's changes are missing, because what happened here at 4 p.m., Stacy actually did an overwrite on what Shane was working on. And that's something that Victoria realized at 5 p.m. So when Stacy updated the module, she overrode the changes made by Shane. And this is a problem that is addressed by version control. I hope you understand the concept of version control and why version control is so important. So there are some related definitions that you should be aware of when it comes to version control. The first one is VCS, or a version control system. Now, if you have multiple programmers that are collaborating on the same project, you cannot do without a VCS. So if you don't have VCS, we just saw what happened. Developers will actually overwrite over each other's code, right? And this is going to create chaos in the project. So this system, the VCS, is going to ensure that every change is tracked, and it lets us see who made what modifications and when. This provides accountability, and this provides ease of tracking as well. The next definition that you should be aware of is known as commit. Now, when a programmer finishes a set of changes to the code, of course, they commit those changes to a repository. So this is like, think of it as saving progress in a collaborative document, right? We all are aware of documents that are shared across the team, and multiple people can work on those shared documents, right? So this is like the same thing, right? You are basically saving progress in a collaborative document, and this ensures that their work is merged with the rest of the project. And this also creates a recorded version of the code which can be revisited later as needed. So commit is again an important definition that you should be aware of. Let's talk about repository. So a repository is like a central library, right? Think of it as a central library where all versions of the project's files, they are stored. And this includes a full history of every single change. This is going to allow the team to work on the same project while knowing that repository stores the most up-to-date version. And this is also incredibly useful for finding and even reverting changes if something goes wrong. And finally, let's talk about conflicting changes, right? This is the key. One of the key benefits of VCS is handling conflicts. When two developers make changes to the same line of code, the VCS identifies this conflict and it is going to reject the second change until the conflict is resolved. So the VCS is not going to allow you to save your progress, right? And this is going to make sure that one developer's work does not unintentionally overwrite another developer's work, right? And the developer then resolves these conflicts by reviewing both sets of changes to ensure that nothing critical is actually lost. So now let's take a look back at what would happen in our scenario once again if a VCS is in place. So similarly, at 9 a.m., Shane comes in. He checks out the source from the repository to a working folder on his computer. At 10:30 a.m., Stacy has the source checked out, so she updates it with latest changes. So she had the source checked out already, right? Now Shane is going to commit his module changes back to the repository. At 4 p.m., Stacy is going to commit changes to the different part of the same module. So they are not working on the same parts of the module, right? At 3 p.m., what happened here was Victoria had updated her working folder with latest source. So when she commits a change which conflicts Stacy's 4 p.m. commit, and this is something that she does at 5 p.m., right? So when she commits a change at 5 p.m. which conflicts Stacy's 4 p.m. commit, it gets rejected. So that's how version control system works. I hope you understand this. Victoria has to resolve conflicts before she can commit her code, as there is a conflict with what Stacy committed at 4 p.m. Now you need to note that merge can be really difficult if there are too many conflicts, right? We just talked about Stacy and Victoria, but think about a piece of code that is being worked upon by hundreds of programmers, right? And whenever they commit changes, it is likely that they are going to see conflicts, and these conflicts need to be resolved. That is what VCS does, that the commit will happen only after the conflicts are resolved. I'd like to take a few seconds and talk about our PM 101 training session. You can head over to pmclounge.com/PM101. If you are new to project management, this is your gateway to the world of project management. Check out this free training. It's a 1.5 hour masterclass for anyone who's trying to get into project management. If you are already into project management, this is a great refresher. Over 500,000 people have watched this video on YouTube. It's a 1.5 hour YouTube video. Definitely check it out. All right, let's talk about XP practices for feedback. Now, Agile is obviously all about feedback, right? Agile practices aim to provide teams with early and frequent feedback. Each iteration is going to help the team gather information to improve planning for the next iteration. And this creates a feedback loop. There are 4 key XP practices that enhance feedback, both in design as well as in coding. First is pair programming, second is a 10-minute build, third is continuous integration, and fourth is TDD, known as test driven development. As I mentioned earlier, Agile is all about feedback, and extreme programming is going to take this a step further with practices like these that are designed specifically to get feedback early and often. Now, in the next section, we will talk about all these 4 practices in detail. Let's start off with pair programming. What exactly is pair programming, right? Now, this technique involves 2 developers working together at just one computer. Now, it's not just about one person coding and another person watching, right? That's what a lot of people tend to think. Actually, this is a collaborative exercise. This involves constant discussion, it involves brainstorming, and it also involves problem solving. And the team is going to rotate pairs frequently so everyone remains familiar with the code base and everyone contributes to the overall design. And this is obviously a great way to cross pollinate ideas and knowledge while catching mistakes early as well. Let's talk about 10-minute build now. 10-minute build, it sounds interesting, right? What is the team doing in 10 minutes here? Now, the team is going to set up an automated build process that compiles code, it runs tests, and creates deployable packages within 10 minutes or less, right? So obviously, since we are talking about 10-minute build, this is something that we can assume is going to happen every 10 minutes. So what's happening every 10 minutes? The code is being compiled, the tests are being run, and deployable packages are being created every 10 minutes. Now, when you keep the build time so short, the team can run it way too often. And this is going to help them get feedback from the system on whether the new code works as intended or not. And this practice is going to reduce the time between writing code and knowing if it's functional, encouraging frequent integration, and even testing. So that's what 10-minute build is all about. Let's talk about the other 2 practices that we mentioned earlier. And the first one is continuous integration. So what's happening here is that every developer is going to integrate their code into a shared repository as often as possible. And this would also mean multiple times a day. This practice is going to ensure that no one's working folder becomes outdated. This is something that we saw in the previous scenario, right? Where Victoria tried to commit and that's when she found some conflicts, right? So if you do this often, if you integrate often, it is likely that you will not encounter such issues. So obviously, this is going to ensure that everyone's working folder is up to date, and it also prevents last minute conflicts. And even if issues arise, they are easier to resolve because changes are recent, right? It's not like someone's trying to resolve a conflict which is 3 days old and so much code would have changed in the last 3 days, right? So that is why continuous integration is important. Continuous integration, it also helps teams stay in sync and allows for faster feedback on the overall health of the project itself. Now let's talk about TDD, or test driven development. This is again a very interesting concept. It basically emphasizes that teams write a failing unit test before working on any new code, right? Think of it this way. What you're doing is you're writing a test case which will fail. Now, what happens then is that it is going to create a tight feedback loop. First, the test fails, then you write just enough code so that the test actually passes. Now, each test is going to give you instant feedback on what works and what doesn't work. Over time, this practice will not only result in cleaner, more reliable code, but it is also a better understanding of what the code needs to do, right? This is going to foster that. So these are the 4 important practices that XP teams use. Together, these practices foster an environment where feedback is continuous and improvement is constant, and it helps the team adapt to changes and avoid any future issues, right? Perfect. Now let's talk about refactoring or refactor. What exactly is this concept all about, right? So think of it this way. What should the code do? Now this is a TDD feedback loop, which we saw in the previous slide as well. What should the code do? You write a unit test that fails. Then you write code that makes the test pass, and you move to the next piece of functionality, and you again ask what should the code do, and then you again write a unit test that fails. Then you again write just enough code so that the test passes, and you move on with your next functionality. So refactoring, actually it involves restructuring code without changing its behavior. So you are restructuring code without changing its behavior. So there's this cycle that TDD follows, right? This process is baked into this cycle that I was talking about, red, green, refactor cycle. So during the red phase, developers start by writing a test that fails. So this is the red phase right here, right? You are starting things off by writing a test case that fails. Now they will move to the the green phase, and the green phase is where they write only the bare minimum amount of code that will help them pass the test, right? So that's the green phase. Now once the test passes, it's time for refactor phase. This is important. This is where the team is actually optimizing the structure of the code without altering its behavior. So you are optimizing the code for simplicity without changing or altering its behavior. And this step ensures that the code remains efficient, clean, and maintainable as well. And the test should still pass, right? It should not be like you did refactoring and the test didn't pass anymore. The test should still pass after refactoring, and this confirms that no functionality has been broken. So this entire cycle, it helps developers improve the code incrementally because they keep doing this, they keep following this cycle, and it helps the developers improve code incrementally. It builds a solid foundation of working tests as well. So this is the entire concept of refactoring. We will come back to this. We will also talk about where it helps, but I hope you understand what refactoring is and how important it really is. Now let's talk about the 5th value of extreme programming, which is simplicity. Now you might think, how come we are talking about the 5th value of extreme programming? We just talked about feedback, right? And as I mentioned, the second link in the description will take you to an entire playlist of all the videos that we have done so far on XP, and that's where you will find the other values of XP. You will find individual videos on respect, courage, and communication. Those are the 3 values of XP that are applicable to all sorts of projects. And in this video, we have already talked about feedback. Now we will be talking about simplicity, which is the fifth value of XP. All right, so when you're solving a programming problem, there are countless approaches that developers can take, but not all are equal. Some solutions are going to end up being more complex than necessary, right? With multiple interconnections, let's say between the units of code or between the modules of code, and this might add layers of different logic, and all of these might not truly contribute to solving the problem more efficiently. You are basically making the code unnecessarily more complex. Why is this happening? Because there are many ways to solve a programming problem. So different coders, different programmers will think differently. Now, simplicity in coding has clear benefits. First, it is going to make the code much easier to modify in the future. And even for someone who wasn't involved in writing it initially, right? Which was a scenario that we discussed when we started off with this video. And developers, they don't need to spend excessive time understanding the convoluted logic before they make any changes. And this is particularly useful in dynamic projects where frequent changes are needed, and we are talking about agile, we are talking about embracing changes, so obviously changes will be needed. It's best to write simple code that can be modified later. Now, simple code, it is going to also result in fewer bugs, and even if bugs occur, they are easier to identify and resolve because the structure of the code is straightforward, right? It's not complex, and it is going to allow for quicker diagnosis of issues as well. So simplicity is a core value in XP. It is going to keep the team focused on finding the most direct, clean solution to any given problem. And when XP teams approach coding tasks, they consciously aim for simplicity, right? They value simplicity so much that whenever they are solving a problem, they are consciously aiming to keep the code simple. And of all the different ways, because there are innumerable ways to solve a programming problem. So of all the different ways that a piece of code can be written, the simplest option is usually the best. That's a value in XP, right? This is something that everyone follows. It's a value. And this mindset helps ensure long-term code quality and adaptability, which also prevents unnecessary changes in the future. Let's talk about a bit more about simplicity. How does a code get complex? Now, this is important to understand, right? Why is the code getting complex to begin with? Now, the point is, code complexity, it often occurs when a unit of code is designed to do too much. So you've wrote a single unit, a single module, and you are asking that module to do too many things, right? So if you have multiple functions that are packed into a single piece of code, it becomes harder to understand, it becomes harder to modify, and it becomes harder to debug. So one of the most effective ways to reduce this complexity is by breaking code into smaller units, into smaller modules. And these focused units should each be ideally performing a singular function. This is going to improve the readability, maintainability, and the overall quality of the code. Now let's talk about how refactoring is going to help you in all of this. We already talked about it. Refactoring involves restructuring code without changing its behavior. So we are only restructuring the code, making it simpler. We are not changing any functionality, right? Obviously, refactoring is an essential part of reducing complexity, right? So in XP, there is an understanding that there are always opportunities to improve and optimize code. This is very important for all programmers to understand. So just because a problem is solved, it does not mean that the solution is perfect. And that is why teams in XP, they continuously refactor their code. That is, they continuously restructure the code without changing its functionality, making it simpler, right? And making it more efficient than it was originally. And this iterative process helps keep the code base lean and adaptable to future changes as well. Now, there are some winning habits that XP teams have. A unique aspect of XP team is their emphasis on forming winning habits. Instead of forcing discipline, right? Instead of forcing that you do refactoring, instead of forcing that you write unit test cases, right? It is something that team values so much that these practices are basically second nature. Refactoring and writing unit test cases, these aren't just tasks to check off a list, right? They are ingrained into the team's daily workflow. And by making these habits a core part of the XP mindset, teams create a culture that fosters continuous improvement, right? So these are the three things that are very important in ensuring that simplicity is maintained across the board and how the code can be as simple as possible. We'll also talk about tech debt a bit. This is again a very important concept. Technical debt basically arises when developers leave complex code or design issues unaddressed. Now, oddly enough, writing complex code is actually easier than writing simpler, more maintainable code. Think about it for a minute once more. Writing complex code is easier than writing simpler code, which is more maintainable for the future, right? So many programmers, they don't go back, even if they, write complex code, many programmers don't go back to improve their code, and this is basically because of time constraints. Let's not forget that we are talking about XP. Let's not forget that XP has weekly cycles, right? Every week the team needs to churn out something new, so obviously they are short on time at all times. And even though refactoring is a habit they would like to maintain, there are deadlines and there are other priorities that often prevent the XP teams from going back and refactoring the code. So over time, this accumulation of complex code, which actually requires refactoring, and even complex design issues, this is known as technical debt, right? The accumulation, right? Because you didn't have time and you had to accumulate complex code without refactoring it. That's called tech debt. So much like financial debt, if this is not managed properly, it can pile up and it can become a major burden for development teams. So XP teams, what they basically do is they manage technical debt by building Slack, right? By including Slack into their weekly cycles. Every week they are churning stuff out, but they add some Slack hours, some Slack time, which is basically extra time allocated specifically for refactoring and improving complex code, making it simpler. And this way they can pay down their technical debt regularly instead of letting these problems pile up. And XP teams also address them incrementally, cycle by cycle. They also follow a practice which is called refactor mercilessly. And what this means is basically being relentless in the effort to clean up the code base and improve it consistently, doing this over and over again every week. There's another concept here which is known as code bloat, and I thought would be good to mention it here. This happens when developers are basically unwilling to delete unnecessary piece of code, even if it's redundant or not being used. So it could be dead code, it could be extra functionality which is not required. If that stays in the code base because it's already been written and the coder does not want to delete it, right? So that's code bloat. And in extreme programming, you have to avoid code bloat because it's key part to keep your technical debt in check, to keep your code clean, to keep your code efficient and ready for accepting changes and being as lightweight as possible. All right, before I let you go, here's the question for this video. Which of these concepts, we talk about different concepts here, right? So which of these do you think can be directly applied to non-software projects, right? So as you can see, XP practices and values, they provide definitely a robust framework for modern software development teams. But the question is, for non-software projects, which of these practices do you think can be used as well. And that's all that we had in this video. I hope you got value out of it. I hope you were able to understand the different XP concepts that we talked about. Definitely check out the first link in the description if you are into reading articles and would like to read about any of these concepts that we discussed today. I'll catch you guys in the next one. Bye bye.